150.
This one's what? This one's 150?
Yeah.
Okay, the sum of these two internal angles. The sum of the internal angles. Equals n minus 2 times 180. Okay, so this, so we have 1, 2, 3, 4, 5 sides. 5 minus 2 is 3. 3 times 180 is 540. All these should add up to 540. Look good? Okay. The equation. Azimuth n plus 1 equals azimuth n plus minus 180 plus minus the internal angle. Okay. We need an azimuth here. Let's say this is north. We'll say that's 45 degrees. Why not? Okay. What direction are we going? Clockwise. We're going in clockwise direction. What does that mean as far as our equation here goes? We subtract the internal angle. So this plus or minus turns into a solid minus. Had it not, had we gone the other way, we'd be adding that internal angle. Okay? Let's set up this table. Bearing, station, line, azimuth, reverse azimuth, internal angle, azimuth n plus 1. We have station A, B, C, D, E, back to A, making line AB, BC, CD, DE, EA. Tickling my face. Okay. What is the azimuth of line AB? 45 degrees, it's given. AB, 45 degrees. Okay. What? So, if I were to come up here, this is 45 degrees. Right, I want to get the reverse azimuth of the azimuth of BA. So I'm going to go 45 degrees. I'm going to subtract 180 degrees to get the number of degrees from here all the way around here. Okay. So I'm going to add or subtract 180 degrees. I'm going to go ahead and add 180 degrees to this, leaving me with 215. Yeah? No. 225. Yeah, 225. Is that correct? Yeah. Okay. All right, am I going to add or subtract my internal angle? Subtract. I'm actually going to subtract all of my internal angles. Okay. What internal angle am I going to subtract?
B.
ABC, angle ABC. So I'm going from line AB, and I'm trying to use line BC. Therefore, the internal angle I'm going to use is internal angle ABC, which is 140. Yeah? So I'm going to subtract out 140, and I'm just going to go around and fill out the rest of these. 105, 150, 80, and 65. Okay. 240, or 225 minus 140. 85 degrees? So what I'm saying is the azimuth of BC is 85 degrees. Yeah, well, let's just pretend that's good. Maybe it's not scale. Okay, so this 85 comes here. Okay. Am I going to add or subtract 180? I'm going to add 180. Why am I adding 180?
Because it's below 360.
You have to keep the solution below 360. Or because this is less than 180. If we're more than 180, I would subtract it. If we're less than 180, I add. All right, that leaves me with 265. All right, and I'm going to add or subtract this. I'm going to subtract out 105. We need 160. 160 would be CD. Yeah, I can see that would be 160. $106 degrees. Am I going to add or subtract 180? Add. Leaves me with 340 degrees. I'm going to subtract out my internal angle of 150 degrees. 190 degrees. I'm saying that DE is 190 degrees, which is reasonable. Okay? 190, am I going to add or subtract 180? Subtract, leaving me with 10 degrees. All right? Now I'm going to subtract out 80. Leave me with negative 70 degrees. What do I do here?
Add 360.
Just going to add 360. Equals what, 290?
Yeah. Okay, I figured out what I did wrong.
You didn't add the 360 back in there?
Mm-hmm.
290. I'm going to see, is this EA? EA looks like it could be 290. Yeah, EA could be 290. I'm going to add or subtract 180. Subtract, leave me with 110. 110 minus 65 equals 45 degrees. This and this. Now I did just whole degrees to make this example easier, but it's going to be degrees, minutes, seconds, or whatever. Yes.
What was the goal?
The goal was to find the azimuth of all the lines.
Okay.
So we only had one azimuth, but we had measured the internal angle. So if you in your survey lab had the azimuth of one of the lines, you could find the azimuth of all of the lines of your control points.
So wouldn't that whole column be our answer?
This whole column is your answer.
Okay.
All right, this whole column is your answer. But you calculated AB after going around the traverse. You were given AB, so it makes sense. All right, let's do the bearings real quick. We're going to convert these into bearings. Okay. The azimuth between 0 and 90. This is north azimuth angle east between 90 and 180. It is south 180 minus the azimuth angle. Yeah. this is between, 180 and 270 is south. Azimuth angle minus 180 west, and this would be east. And if this is 270 to 360, it is north. 360 minus azimuth angle west. Okay. 45 degrees, it is less than 90, so it is north. 45 degrees east. 85 is again in the first quadrant, so it is north. 85 degrees east. 160 is in the second quadrant, therefore it is south. 160, or 180 minus 60, so it's south. 60, 180 minus 160 is 20 degrees. 20 degrees east. This is in the third quadrant, so it's south. 190 minus 180, 10 degrees west. And this is in the fourth quadrant, which would be north. 360 minus 290 is 70 degrees west. And then if we were going to convert back to whatever, we can convert from bearings to azimuth. Quadrant, we'll say north, east, south, east, south, west, and northwest, and azimuth. The bearing angle equals the azimuth. And this one, what is it? It would be minus 180 minus the bearing angle. And this one will be 180 plus the bearing angle. And this one would be 36 minus the So the bearing angle, right, it's north, bearing angle east, right? Bearing angle is the azimuth, 180 minus the bearing angle, 180 plus the bearing angle, 360 minus the bearing. And so you convert back and forth between the two. Good? Erase this.
Is our exam next week?
Yes.
How many exams are we having?
Midterm and final. How many credits is this class? One?
Yeah.
Yeah. Midterm, final, homework, 1 credit class. Seems reasonable. Okay, you want to do chain corrections?
Yeah.
Alright. Step 1. fill out table. Alright, so we'll have field, standard, and some kind of miscellaneous. Field, you'll have a temperature, pressure, an erroneous length, and a sag. Standard, you'll have a temperature, a pressure, S, a standard pressure, a standard length, and a standard sag. And miscellaneous, you'll have like in cross-sectional area, you'll have E, you'll have K, you'll have a weight of the chain, you'll have the length that was measured. What else would you need? That looks about right. Okay. And then we'll have our corrections. Everyone done with this? Yeah. So we'll have the L corrected equals L plus the correction for the erroneous length plus the correction for temperature plus the correction for pressure plus the correction for sag. Correction for the erroneous length equals L minus LS, L over LS. The correction for temperature equals K, T minus TS. L, the correction for pressure equals pressure minus PS, L over AE. And the correction for sag equals the standard sag minus the sag, W squared L over 24P squared. Yeah. So, oh, you also have the grade. Okay. So this L corrected equals either L horizontal, L vertical, or L slope. L corrected, and that'll be stated. Okay? So, with the grade, if I give you a grade of 3.5%, what is that telling you? It's telling you that this measurement is, this triangle is similar to a triangle that is, for every 100 feet over, I go 3.5 feet up. This triangle is similar to this triangle, which means this alpha, this degree, is equal to this alpha. Right? That means alpha, the tangent of alpha equals my grade divided by 100. Or, more importantly, the tangent inverse of alpha equals the grade as a decimal. Nope. Alpha equals the tangent inverse of the grade represented as a decimal. What does it mean when I say the grade represented as a decimal? instead of a percent sign, it is 0, so 3.5% actually equals 0.035 as a decimal. Yeah? I just divided it by 100. So the grade, the actual grade 3.5 divided by 100 is going to give you that. Right? Then with knowing that this is a right triangle, with this alpha and one of these values, you should be able to solve for all. And if you can't do that, then you have some studying to do. Yes?
Are you giving us those equations? Do we need to memorize them?
So you guys are gonna make your own 5x3 index card formula sheet. Sturgis is unpleased with this.
That's because you can't hand it out.
Sure, we'll go with that. No, I always do this, because this is a sophomore class, I don't want them to fail. So, you can do both sides, we'll get nuts. As long as it's handwritten, doesn't have to be your handwriting. Handwritten, no non-prescription visual aid devices. Magnifying glasses and such.
No, what's
Do you
that?
have a formula sheet on camera somewhere with these?
Maybe, yeah, probably.
Can we just bring that?
Is it printed? I mean, it's probably up there.
I'm not seeing it.
Bring your own. Just bring your own. You're gonna write 5 equations on it, you'll be set. You'll probably do it the day of too. Oh, sorry. See how unamused Sturgis is? Sturgis is a senior. So this is like, he's so abused and been neglected for so long, and this is nothing to him. I don't know why you waited till your senior year to take this, but it's my boy. Okay? So, the question was, how do we know what goes where? Yeah? Well, this is gonna be in inches squared. This is gonna be in PSI, or pounds per square inch. This is per unit degree Fahrenheit. This is in pounds. This is in feet. And this is in percent. That helps. This is in degrees Fahrenheit. This is in pounds of pressure. This is in feet. This is unitless. And the same thing goes here. This is degrees Fahrenheit. This is pounds of pressure. This is feet. And this is unitless. Okay? It's going to say whether it's standardized or not. A tape was standardized at 68 degrees Fahrenheit and had a standard length of 100 feet. Most tapes are standardized to be 100 feet. They're 100-foot tapes. Most temperatures are going to be high 60s to low 70s for standardized temperature. Pressure's like 15 pounds. And generally it's without sag, but you'll just have to read that. And these will be everything in the field. Was used to measure. This tape that was standardized was used to measure and all of these things. Good? Want to do leveling? Real quick. should probably do this. Step 2 for this one, would be solve correction equations. Step 3 would be solve for L corrected. Step 4 would be solve for L horizontal, L vertical, and or L slope. And that would be it. Great.
Did you just do that in your head?
Well, I'm giving you this as in this was the known value, so I wanted to make sure that it was something close. So. Yep, okay. We'll go step 1. Make table. Okay, so we'll go station, backside, instrument height, intermediate station, foresight, elevation. We'll go EM1, then we'll go 20.1, alpha, beta, turning point. No, this is all too 2, and then we'll go benchmark 2. Okay? So, benchmark 1 has an elevation of 100 feet. Maybe I'll use new markers, was kind of running the gas. $100 feet. Okay? Does benchmark 1 have a backside? Yes. Right. This is the direction of survey. We're looking backwards. So if we're standing here, doing our survey thing, and we're very happy, I'm looking in the opposite direction of my direction. I'm looking backwards. That is a backside. Okay. I have a backside of 3.0. I'm going to add my elevation plus my backside is going to give me my instrument height. 103. That means that the elevation of, so this is 100 feet, and this is 3 feet, yeah? Therefore, this line is 103 feet elevation, yeah? Okay. Does turning point 1 have a foresight? Yes. What is turning point 1's foresight? 4.0. Okay? That means that the elevation of turning point 1 is 4 feet under this 103. Underneath it. I'm going to so my instrument height minus my foresight is going to give me my elevation of 99 feet. Then I'm going to leapfrog back to here. Okay? Does my turning point 1 have a backside? Yes. What is that backside? 1.5. Right? Turning point 1. I know now that the elevation here is 99 feet. I'm looking backwards and seeing that my instrument is 1.5 feet above 99 feet. So my new instrument height is therefore that means that the elevation of this line is 100.5. Okay? So, alpha is located 2 feet under this line. Beta is located 2.5 feet under this line. And then my foresight for turning point 2 is 3.5 feet under this line. I'm continually coming back to this line. So, alpha has an intermediate station of 2 feet, and beta has an intermediate station of 2.5 feet. So, it is 100.5 minus 2 is 98.5, and 100.5 minus 2.5 is 98. Okay. My turning point has a foresight of 3.5. Leaves me with 97 feet. Bless you. Now I'm going to leapfrog over here. Okay. And I know that this elevation is now 97 feet. And my new height is 3 feet above 97 feet. So benchmark or turning point 2 has a back sight of 3 feet. And that means I have an instrument height of 100 feet. So this line is located at 100 feet. Yeah? My benchmark 2 has a foresight of 4 feet. Right? Resulting in an elevation of 96 feet. Okay? I'm going to do percent error. Well, I'm going to do an algebraic check. Alright, that means that my initial elevation plus the summation of my back sights, I, minus the summation of my foresights is going to equal my final elevation. Okay, so I'm left with, what did I start with, 100 feet? 100 plus 3 plus 1.5 plus 3. And I'm going to subtract out 4, subtract out 2, one of these is in the wrong spot. Both of these are in the wrong spot. 0. I'm going to subtract out 4, I'm going to subtract out 3.5, and I'm going to subtract out 4. And the question is, does that equal 96? Well, it's 1, 2, 3, 4, yes. And the answer is yes. Okay? And then we're going to do a percent error. So the known value is this. That's the value of known minus the estimate over the known equals 100 times 96.5 minus 96 over 96.5, maybe like 0.07%. No, yeah, it's like a 0.5%.
Yeah, 0.52.
0.52 equals 0.52%. Voila. Step out of the way. So I would expect one of each of those 3. I'll probably do something similar to the quiz also at some point on the test. And then some like theory stuff. Sounds completely reasonable. Literally telling you everything on the exam. I do reserve the right to mess with you a little bit on the closed traverse. Daniel's like, no. By mess with you, I mean, maybe instead of giving you an azimuth, I'll give you a starting bearing or something.
We can handle that.
Yeah.
Say that now. I'm gonna get cursed. You guys gonna have voodoo dolls of me. You should see the 311 test. They literally have a voodoo doll of me. They're like poking and kicking.
Yeah, if you're alive after that 311 test, I wouldn't worry.
I'm literally giving you guys a redo, a mulligan. It's because it's a disaster.
I don't have to do that.
You don't. You did well the first time.
I'm gonna try, but I did not study.
Okay. Any questions? Everybody, yes.
Could you please,
Step out of the way.
sorry.
Yeah.
I'll try to get this video posted today.
Serge, are you gonna get an A on this?
Probably.
I think so.
What have been waiting on?
What's up? Just an opportunity to excel.
I'm shedding.
I clearly. She just takes one straight here.
I have to, like, mark my territory.
Clearly.